All right, let's dive right into this explainer. We're going to decode a massive shift happening right now, moving from traditional software APIs to a world driven entirely by AI agents talking to each other. I mean, we're literally looking at a fundamental rewrite of how digital systems interact, moving away from rigid code and toward intelligent negotiating agents.
To understand this properly, here's our roadmap for today. We'll start with the vision of Agentia, move beyond traditional APIs, break down the Google A2A protocol, and then dive into building, containerizing, and finally deploying these agents to the cloud.
So, starting with Section 1, the vision of Agentia, and welcome to Web 3.0. We're actually transitioning from the web as we know it today to a dynamic, living network called Agentia, where everything, from your coffee machine to the passport office, is an intelligent agent.
There's this quote that really hits the nail on the head. Systems will no longer communicate through outdated APIs, but through sophisticated, intelligent dialogues. In this new paradigm, instead of structured, rigid data, our systems are going to use real dialogues. Just imagine a world where your calendar doesn't just block out a date, but actually negotiates with an airline's booking system, in plain text, to secure your flight. It's wild. Moving right along to Section 2, Beyond APIs and the Natural Language Era. Let's see how this shift builds upon and honestly ultimately replaces the 40-year-old API standard.
Look, for decades, APIs have been the absolute backbone of software, but they have a massive limitation, right? They require a super rigid structure. If you change a single parameter, boom, the whole thing breaks. And more importantly, while traditional APIs require you, the human, to navigate complex user interfaces just to book a flight or update a record, agent-to-agent communication is entirely autonomous and unstructured. It relies on natural language, text, audio, or even video, letting the AI just figure out the parameters on its own. Think of it kind of like going to a human passport expert. You don't need to know how the complex government database works or, which exact drop-down menus to click. You just hand over your documents, state your goal, and the expert negotiates the entire system on your behalf. In this new Agentia world, that human expert is simply replaced by a domain-specific AI agent. But that brings us to a really crucial question. If APIs and their rigid endpoints are fading away, what is the exact mechanism allowing these totally disparate AI systems to communicate? Like, if my personal calendar agent needs to talk to the airline's agent, how are they actually connecting?
Well, that brings us to Section 3, Google A2A protocol and agent communication. To solve this exact problem, Google recently launched the Open Agent-to-Agent, or A2A, protocol. And let me tell you, it's already making huge waves across the industry.
This shift has been so incredibly sudden that even massive early innovators, like the popular AI framework LangChain, which was sitting on over 11,000 GitHub stars, found themselves holding on to just about 10% of their original market dominance. They literally had to quickly adopt and align with Google's new protocol to avoid losing relevance in this incredibly fast-moving space. You simply cannot ignore an open standard for agent communication. So here's how it actually works in practice. Google's A2A protocol connects three key actors. First, there's you, the human user who actually initiates the task. Second is your client agent. You can think of this as your 24/7 personal assistant that lives on your device and actually knows all of your context. And third is the remote agent. This is the external domain expert we talked about, like a LinkedIn agent or the passport office agent. Now, here's where it gets really clever. If there are no structured APIs, how does your client agent know what the passport remote agent can actually do? Well, instead of reading rigid API documentation, it reads an agent card. It's just a simple file called agent.json. It basically acts like a metadata ID card, allowing agents to instantly self-discover each other's capabilities across the web using really lightweight data protocols.
Okay, so we've covered the language they speak and how they discover each other. But where do these intelligent programs actually live? How do we ensure they don't just work on some developer's local laptop, but can scale up to handle millions of users globally?
That takes us to Section 4, Building Agents and Containerizing AI. Let's look at the cloud-native infrastructure required to keep these agents alive, using tools like Python, OpenAgent SDK, and Fast API. When we're packaging up these agents, we use Docker containers. This acts a lot like moving a native tree with its original soil and roots. Think about it. If you take a seed from one environment and plant it in completely foreign soil, it might just die. But by packing the environment
all the dependencies and the operating system together in a container, we ensure your code runs perfectly no matter what cloud environment it gets planted in. And because these containers are lightweight and stateless, we attach something called a Daper sidecar. Think of it playfully like the sidecar on a classic vintage motorcycle. This companion sidecar rides right alongside your main app to robustly handle memory, state management, and communication between services. It essentially takes all that complex networking logic completely off the developer's plate. Finally, we arrive at Section 5, deploying to cloud and scaling for the world. Let's explore how we actually take these containerized agents and deploy them to the cloud so they can handle traffic from everywhere. To manage millions of users, we rely on Kubernetes. This is an orchestration tool that scales your application pods up and down based on real-time demand. It's very much like a caterer. If only a few guests show up, you only bring out one pot of biryani, right? But if a massive crowd suddenly arrives, Kubernetes automatically brings out 50 pots to handle that load, and then scales it right back down when the crowd leaves. That way, you aren't paying for unused cloud resources.
When deciding exactly where to deploy this, developers have a progression of choices. You could go with self-managed Kubernetes, which gives you 100% control, but leaves you with the absolute maximum operational overhead. I mean, you're managing the hardware, the AC, the electricity, the whole shebang. Alternatively, you can hand off about 50% of the work to semi-managed services like Google Kubernetes Engine. But for modern agent development, most teams are moving towards serverless platforms, handing off 85% or more of the operational headaches straight to the cloud provider. If we look a little closer at those serverless options for production-grade agent architectures, Azure Container Apps is often highly recommended. Why? Well, because it offers built-in Dapr support right out of the box, handling that sidecar logic we just talked about. On the flip side, Google Cloud Run is incredibly fast for deployment and leaves you with only 10% manual management, but it currently lacks that native sidecar framework. So it's a real trade-off developers have to weigh carefully, based on how complex their agents' communication needs actually are.
I really hope this explainer helped you wrap your head around the A2A shift. We're moving away from just clicking buttons on a screen to having literal armies of digital experts negotiating on our behalf in plain language. But this leaves us with a really critical question to ponder. As these agents begin acting autonomously, self-discovering, and consuming vast amounts of cloud resources, are we truly ready for the Agentia revolution? Definitely something to think about. Thanks for learning with me today.